Hey everybody, Mr. Reeves here once again as we continue looking at rational and irrational numbers. So remember, a rational number is any number that can be written in the form a over b, where a and b are integers and b is not equal to 0. An irrational number is any number that when it's written as a decimal is non-terminating and non-repeating. All right, so today we're specifically going to be looking at square roots. All right, so right here it gives us the definition of a square root. A square root of a positive number x if x squared is x, if x squared is p. All right, in other words, if you square a number and get p, if you work backwards from squaring it, you get the square root. All right? So you have a principal or primary square root, which is positive, and then you also will have a negative square root. All right, by the way, we're only going to be taking the square root of positive numbers. Under real numbers, you cannot take the square root of a negative number, but that's a discussion for another day. So for example, if we take a look here, they take a look at the number 36, and they say that the square root of 36 would be both positive and negative 6. So if we were to look at that, if we take the square root of 36, well, what do we know? We know that 6 times 6 is 36, or another way to say that is 6 squared is 36, right? But we also should know that negative 6 times negative 6 is positive 36, right? So negative 6 squared is 36. So if I ask you what number times itself is 36, it could be 6 or it could be negative 6. So since it could be either one, this is what we do. We say if we want the positive or the primary square root of 36, we just don't put anything there. If we want the negative square root of 36, we put the negative there. And sometimes we do this to say we want both of the roots of 36, and we put plus or minus, even though it's positive and negative. I don't know why, as math people, we say plus and minus 6, okay? So again, that's how square root works. That's the square root symbol. It means what number times itself gives you that number. You will always have one positive answer, and you will always have one negative answer. And again, we're not going to right now be looking at the square root of negative numbers. All right? Okay, you can also take the square root of fractions like they did here, the square root of 125. You simply square root the top and you square root the bottom. All right, and sometimes you'll hear us talking about a perfect square. A number is a perfect square that has a square root that is an integer. All right, a number is a perfect square that has a square root that is an integer. And the square root of a perfect square will be rational, or the square root of a quotient of perfect squares will be rational. All other square roots will be irrational. All right, and what do I mean by a perfect square? Well, what are some examples? So I have this table here. It happens to have squares and cubes. We're going to be doing cubes next, by the way. Stay tuned. All right, so we take a look here. And we start, and this table only has positives, by the way. We could put negatives on these, and these would be exactly the same, right? So actually, if I wanted to, right here, I could put plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, right? Because 1 squared is 1, 2 squared is 4, 3 squared is 9, right? So this table shows you this middle column. Those are all perfect squares. You should recognize those numbers as perfect squares. And it would be very, very helpful to you if you could memorize, like if you knew those first 20 perfect squares, that would save you a lot of time and trouble. So if I say is 81 a perfect square, or is 169 a perfect square, or is 256 a perfect square, knowing those and knowing the square roots. If I said, what's the square root of 361? If you could tell me 19, right? Okay, because if what we have here is we have 19 squared, right, is 361. So what does that mean? That means that the square root of 361 is 19, right? 16 squared is 256. So what does that mean? That means the square root of 256 is 16. All right? So again, anytime you take the square root of a perfect square, it will be rational. Or if you take the square root of a quotient of perfect squares. So let's see here. How about if I put 225 on the top? I got from right there. And I'll put 289 on the bottom. Okay, now this is not, the fraction itself is not a perfect square. However, 225 is. So what this actually becomes is the square root of 225 over the square root of 289. And again, since 15 squared is 225, the square root of 225 is going to be 15. And 289, since 17 squared is 289, the square root of 289 is 17. So you can see when we took the square root of the quotient of perfect squares, we got a rational number. Okay? All right, so that's how square roots work. So let's take a look here at this top part of this worksheet that I have here. All right, and again, you will see that we have both positive and negative square roots. Again, the positive being called the primary or the principal square root. All right, and again, if you do not have these memorized, then you can refer to that table. That table will be posted in Google Classroom for you. You can also find online very quickly lots and lots of tables of perfect squares. Okay, so let's start with some of the smaller ones. How about this one? The square root of 0. What times itself is 0? That is 0. What about the square root of 16? That is 4. What about the negative square root of 4? Well, that's going to be negative 2. What about the negative square root of 49? That's going to be negative 7. You see how that works? All right, 361. I'm not sure about that one. Let me go back to my table here, and let's see if I can find 361. There it is, right there. 19 squared. All right, so the square root of 361, whoops, here we go. The square root of 361 is 19, so this one would be negative 19. So if you don't know what they are, you can look them up. And then here we have some quotients, some square roots of quotients. But remember, these are perfect squares on the top and the bottom. So this is going to be a negative. What's the square root of 9? 3. What's the square root of 81? 9. And of course, we're going to simplify, and we're going to get negative 1/3. If some of you are going, well, wait, could I have simplified this to 1/9 before I took the square root? The answer is yes. All right, what about this one? The square root of 4 is 2. The square root of 16 is 4, and that simplifies to 1/2. And again, if you wanted to, you could have simplified it first and then taken the square root of 1/4. Okay, see how this works? Square root of 64 is 8. Square root of 81 is 9. Square root of 4 is 2. Square root of 49 is 7, but this one they want to be negative. All right, so that's taking square roots of perfect squares. But what if they're not a perfect square? And most square roots will not be of perfect squares. All right, so I have this table here. And again, I just pulled this right off the internet. Let me make this a little bit smaller so we can see the whole thing. All right. Wow. Okay. We can almost make it fit. Okay. So I'm at 75%. That's about as small as it can get for these old eyes. All right. So if you take a look, you should see the perfect squares here. All right. 1, 2. These are the ones right here. Actually, the perfect square is the part inside the square root. But do you see how when you take the square root, I'm getting an integer answer, right? So the square root of 1 is 1. All right, so 1 is my perfect square, and there's my square root. 4 is my perfect square. 9 is my perfect square. 16 is my perfect square. All right, and we can't see it. Here we go. If we scroll, there's 25 and 5. All right, and you see how there's a ton of them in between, and there's even more because these are only taking the square roots. So what do you do if it's not a perfect square? All right, well, the easy answer is you use a calculator. All right, all of these are going to be irrational numbers. If you are taking the square root of a number that is not a perfect square, or the quotient, or I guess I could say product too, I could throw that in there. But if what's inside is not made up entirely of either multiplying or dividing perfect squares, then you're going to get irrational numbers. So even though they stop on this table, these numbers, these decimal numbers, go on forever and ever and ever. So I'm never going to ask you without a calculator to tell me what the square root of 59 is, okay? Or I'm not going to ask you, say, what's the square root of 88? It's not something you're going to have to do by hand, like long division or multiplication. So if I'm asking you to give me a value, I'm going to say go ahead and use a calculator. But that's not what I'm going to be asking you to do. I'm going to be asking you instead to estimate them and tell me what they are between. So if we go to the bottom of this worksheet here, for each problem, give the two integers that the square root is between. Then circle the integer that it is closer to. All right, so let's start with one that maybe you would be more familiar with without having to look it up. All right, so let's take a look right here at the square root of 102. 102 is not a perfect square. But if I were to ask you, what is a perfect square that's close to 102? I hope you could tell me 100, right? The square root of 100 is 10. And here I have the square root of 102. And what's the next bigger perfect square after 100, right? 10 squared is 100. What's 11 squared? It is 121, right? So if I said give two integers that the root is between, it's between 10 and 11, right? The square root of 100 is 10. The square root of 102 is 121. And I hope you can see that 102 is a whole heck of a lot closer to 100 than it is to 121. So I'm going to go ahead and circle 10 right there. All right. All right. What about right here, negative 32? All right. So again, I'm going to write the square root of 32 here with a negative, and let's think about it. We want one that's smaller and one that's bigger. All right, so I'm going to have a negative 36 here. Well, the square root of 36 is 6, so that one is negative 6. Then let me ask you, what about negative 5? What would that one be? Well, that one would be negative 25. The square root. I'm leaving off the square roots. I shouldn't really do that when I'm saying that. So the square root of negative 32 is, let me say that again. The negative square root of 32, the negative square root of 32 is between the negative square root of 36 and the negative square root of 25. So the answer for this one is it's between negative 6 and negative 5. Now, which one is it closer to? Well, from there to there, that's a difference of 4. And from there to there, that's a difference of 7. So which one is it closer to? It's closer to negative 6. All right? All right, well, let's say you had one like this. 428, I don't really know. That's not one I have memorized. So 428, I'm going to go back to my table here. 428. Well, I'm going to have to go further. All right, here we go. All right, so right here, here's 400, right? So the square root of 400 would be 20, and the square root of 441 would be 21. So right in between here is 428. So I know it's between 20 and 21, and the question is, which one is it closer to? Well, how far is it from 400 to 428? Well, that is a difference of 28. How far is it from 428 to 441? Well, let's see here. So 30 to 41 would be 11. So that would be 13. So it's closer to 21. All right. So do you see how that works? All right. And real quick, all right, it would be academically dishonest if I didn't just say, okay, if we were working on a calculator, all right, and we went ahead and took a look at that one we just did, all right, the square root of 428. So I'm going to go ahead and go here second, and then I'm going to do my square. There's my square root of 428. And what do I see? All right, it's 20.7 if we round up. And do you guys agree that 20.7 is closer to 21? Do you agree? First of all, it's between 20 and 21, right? It's between 20 and 21, and it's closer to 21, right? So if we went back to, whoops, where did our worksheet go? Okay, if we go back to this worksheet here, and let me pull up the calculator here. Here we go. So let's do like this one, negative 383, right? So I'm going to go ahead and put in the negative right here, and then I'm going to do the square root of 383, all right? There we go, negative 19.57, and so on. This is an irrational number. That decimal is going to go on forever. What two integers is it between? Well, it's between negative 19 and negative 20, right? It's between negative 19 and negative 20. And which one is it closer to? Well, it's almost right in the middle, but because it's 5/7, it's a little bit closer to negative 20. All right, see how that works? All right, what about 318? So if I did the square root of 318, what do I get? I get 17.83. So it's between 17 and 18, right? But it's closer to 18. Again, if I did 17 squared, I get 289. That's smaller than 318, right? If I do 18 squared, I get 324, which is bigger. So 318, because it's between these two integers, is between, the square root is between 17 and 18, but it's closer to this one, right? 318 is closer to 324 than 289. All right. Okay, well, I hope that this video was helpful to you. Again, when you have a perfect square, and you take the square root, it's going to be a rational number. Or if it happens to be the quotient or the product of perfect squares, it will also be rational. But almost every single square root you ever take, will be irrational. All right, because most numbers are not perfect squares or the quotient or product of perfect squares. All right, have a great day, everybody.